How's it going, everyone? Welcome. Euler Gonzalez here again. Today we're going to talk about the front-end system design, specifically at the network phase, right? So how we're going to now, when it comes to build this user interface, we are responsible to several areas. So we now have to take care of the API communication as well as the data management, how we're going to store and manage our data, something that we looked yesterday, and also is how we're going to now deal with complex user interactions. For example, in our case, using is the intersection observer or mutation or resize API that are part from the observer API as a way to know how can we deal is with this concurrency. And this is something that I make a quick pause here because in today's video we're gonna focus is we're gonna look at we're gonna look at the network connectivity, right? So network connectivity. But before getting to this, it's important to describe that, especially as we are now building this user interaction as a JavaScript engineers, we need to know is how these things work. What is the inner mechanism and the tools that allow us to build this user-rich interactions, and how by doing that, where is the foundations of what we're doing? What is the soil of where we are actually building that? That is the single threads. So again, this is not a recap of JavaScript. It's just as a way to understand that as UI developers or a UI specialists, all right, which is part of the jobs that the software engineers actually take care of, as a way to build this kind of applications, whether it's a backend, API, and network, and front-end, okay? So front-end is what we are going to see in today's video, and something that I'm going to dedicate my life, at least at the couple month, and then I'm going to make this, I'm gonna switch off, then I'm gonna swap to, now I'm gonna switch on to the backend side, with using is now Postgres and MongoDB, but as a way to get now more insight and real life applications of that. But this is a UI specialist course as a way to understand what is the fundamentals, and because we're going to look now at this particular area where we need to handle is the network connectivity, and previously we look at how can we now manage our state, our data management, okay? At the end of the day, we need to do that because as JavaScript developers or UI especially, we need to deal is with this concurrency, and this concurrency is multiple tests that overlaps over time, right? So this is now when the concepts of the event loops and having this particular mechanism to deal with this task that can happen or that overlaps over time, okay, is quite important to understand. So not only to manage our data, which is what we saw in yesterday, okay, as a way to again, this is some recommendations, right? This is some recommendations based on based on Yifni Ray, software engineer that has previously worked at JetBrains and now he's currently at Meta. The thing here is that he described this, especially when it comes to now look at the data management and network, like, right, API communications and application state. So yesterday we looked at how can we now build user interface applications, and for that we need to understand what is the type of data that we need to store, right? So we have now the classes of data as well as its property. So most of the time we store is configuration, user preference, local accessibility, that kind of font, that kind of thing. Also the UI state of your application, especially if you're building React applications, right? When you have all of these different UI state that you need to manage locally, such as selecting a box, checking a checkbox state, or an input, that kind of thing. All of these local UI states, and also is the global states, or this data that come from the server that you need to actually manage. So the recommendation here is based on the property that about the data that we want to store and manage, which is the access, the access, how frequent are we going to read and write this data, and also the size of this data. So because the end goal of this application states is to now minimize this read access or this read cost, as well as which is the access cost. And if you have implemented search in operations in your application, you also want to minimize that search as well, and to minimize the memory used for that, right? So this is a specific thing that we need to do, especially if we want to maintain the state of our application. There are already other libraries out there, so for example Redux, that allows to easily do that. So we delegate all of this heavy lifting. Not quite sure if they actually, for example, say, hey, index Redux, right? And by use guides. But in this case, it's as a way to structuring reducers, reducing boilerplates, deriving data for that. Redux tutorial, no, this is Redux tutorial index. Redux, okay. They index database Redux, right? Not sure if they actually with RT-key, which is not the recommending approach to actually use Redux. Let me say is index. Okay. Create store will continue to work indefinitely. Use RT-key query, tutorials, Redux toolkits, reducers and actions. That's quite interesting. That's very interesting. Entity adapter types, create store, no normalize or deduplicate catch. Interesting. This is one of the techniques that we're going to see as a way to now reduce access time, normalize your data. Trade of a concern, extra reducers. Interesting. The Redux doc has always recommend keeping data in a normalized lookup table, right? Normalizing state shape. This is Redux logic and Redux pattern. Okay. Redux logic and Redux structuring reducers. Normalize state shapes, updating normalized data, reusing reducer logic, deriving data from selectors, and that kind of thing. Okay. And designing a normalized state for that. So, okay, organizing normalized data in the states, relationships and tables, right? This is the entity by ID and all ID, books, author book. Okay, not sure if there's a normalizing library. Not sure is okay. This normalizing library has been deprecated due to the lack of the ability to find and invest in maintainer and ability to do routines maintenance. Maintainers want help. But this is archived, so it's over. And I get it why a lot of people actually is not using that, Because API frequently send back data in a nested form, that data needs to be transformed in a normalized shape before it can be included in the state tree. The normalized library is usually used for this task. You can define schema types in relation feeds and schema blah, 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 blah. That output can be included in an action and used to update to store. See the normalizer documentation for that. Updating normalized data. As I mentioned, in normalizing shapes, simple merging for that. Simple reducer composition. And this other approach, task-based updates. Dot prop immutability, object path immutability. Okay, Redux ORM, what in the F? Okay, this is what I was looking for. Okay, Redux ORM, not maintain. Take care, bye-bye. A small, simple, and immutable ORM to manage relational database in your Redux store. This is quite interesting, very, very interesting. And they remove that, so they don't. What was the last time? 3 years ago. Okay, they deprecate that. Redux ORM, a small, simple, immutable ORM to manage relational data in your Redux store. But they. Okay. Why am I looking at this and why am I showing this to you? Because especially when we want is to actually improve the applications. Remember, the end goal of this application state design is to minimize the access cost, also the search operations, and the memory usage. Okay, so each one of them we're limited by time and in space. But the idea here is that by looking at how now React applications and Redux actually try to solve these particular problems, and how now when you need to deal this in your daily life, in your applications, okay, for any company out there, it's important to know what are you going to do. So what is the scale of your application, so the scale of your data, so how many data you're going to store there, and then look at the structure of your data. This is part of the recommendation here. So look at the structure of your data and start with that. So first understand the scale. What is the amount of data that we're going to handle in this application here? And then structure your data from that. So if you need to improve the access time, then normalize your data, which is something that a lot of the time we're gonna do. How can we do that? By following this database normalization concept, which is a way of how you can improve the performance by get rid of the redundance and duplicate data, right? So the point of this is by following this particularly normalizations. The first norm says is all of the fields must be atomic, and it must has an ID, a primary key, which is something that you have here. Okay, there you got this. Okay, all of this data must be atomic, which is you only have must property, it must have a key. This is the first norm. The second form of normalization say, hey, non-primary key must have, some non-primary key depend on the primary key, on the entity primary key, which means is that relevant data must depend on that entity, on that primary key entity. So that's why we started to look at this kind of normalization. However, there are more than 7 types of normalization. Usually in the UI we do only 2, all right? I'm assuming that for a matter of time, you want to solutions. You want to also do some monkey patch here. Hey, can you solve this problem? Yes. Good. Period. So yeah, we got this, right? But is this? So this is atomic. So all of this data is atomic, right? If you have this kind of object, you need to make all of this data atomic. And this is the way how you put this, all of this atomic, flat data. And then, well, this is the first norm, and the second normalization form, it say, hey, a non-primary key depends on entity primary key, which means that you're going to split now all of this data that are relevant to their entities, or create tables out of that, or in this case, create objects, hash tables. So is this? So in this case, exactly. So per ID, you say, hey, this ID, this primary key now contains all of the data, similar for this and that. In the third formal norm, again, most of the time we just reach until the second normal form. And the third formal norm says, well, it follows the second NF and say, well, non-primary key only depends on the primary key, which means that if you have some nested things like that, right? So for example, data that is nested here, you say, hey, this primary key only have this particular data that is relevant to this entity. If you're not, create now a new hash, a new record for that, which is in this case is department. So for the department, you have now is this. So you split that primary key into their own tables. So yeah, so far so good, right? So this is now how can we apply that, all right? And if you want to now implement in search features, all right, as a way to improve now the search or to minimize the search costs, well, use index for that. You can use something called as inverted index table, where you're gonna know in the index store is relevant data that you want to find quickly. So for example, the username or the email or the content of the content. But again, all of it will be depend on which type of data you want to now provide to the user in the most fast way possible. If you have an e-commerce, most of the time you want to do that for showing products, right? You might want to use now an inverted index table as a way to actually is now index or search that data that you already have in memory, so the users can now actually interact with this. And when we're talking about is this size, all right, it's like good. This is now the data that we're going to show. That we need to also minimize the size of the data to choose what is the proper data that we want to show, as well as the data, the proper data we want to show, and the how we're going to offloading the data, and where we're gonna offloading the data, right? So it means that we need to take in consideration what is the relevant data that we want to show to the user, especially if you have an e-commerce. All right, let's say this user is searching for categories, right? So you want to store now those categories in memory, especially categories. Most of the time this is not a trivial thing, by the way, especially on e-commerce, because most of the time this is something that is offloading to the backend test. But you can implement this for small things that you want to improve the performance, right? So for example, small things like searching through to my friends or to my contacts, right? Or to take a look now at the recent orders that I made, right? So filtering is that latest orders. But again, anytime, and also dashboard is something interesting. So anytime you want to now show a specific set of data, and then you want to let that, and when you want to let the user to filter for that and search for that, one way to implement this is by using this inverted index tables. Makes a lot of sense. Again, only implement this if you need to do this, right? Because this not only have to consider is that how many data you're going to store and how many data you're going to show to the users, and then you need to is share the data in the backend, in the front end, as a way to now is offloading those data that is not relevant, show them the proper data, and then swap between them. Okay, those storage that you can use is the local storage, cookie, and IndexedDB. So local storage is persisting across browser season. So if you close the browser and then you open that, it persists that. Season storage is only persisting per tab. If you close that tab, you lose all of the data. And then you have now the IndexedDB, which is persisting even when the user turn off the computer. There's some trade-off in each one of them. That's why we look at this specific recommendations, all right? And most of the time, unless if you're going to work with this kind of big company, they might be implementing this. But in any case, that's why we are looking now at the network connectivity, right? The API communications.
Talk about how we talk to this server. Imagine that we're trying to build the shop administration app with two main endpoints. The one is to track new orders. The second one is to chat with employees. What are the technologies we would use for that? And what is the stack? So let's first overview the protocols available to us. So there are two main protocols. One is UDP. The second one is TCP. The UDP is the protocol that doesn't guarantee the package the package from the server received in the full size. Or you can, so when you receive the data from the UDP, you just request the server, and the server does not ensure that the data is received by the client. So this means there is some data loss in process. This protocol is heavily used in video streaming, where you can lose some data packages throughout the transfer. It will the data, so your video stream quality may lose some bytes, but it's not critical. So it basically provides a response. If the response is not provided, that's fine. The server can continue fire the response. But the TCP is different. TCP ensures that the data requested by the client and sent by the server is received in full. So for that, it does the three-way handshake. So it calls the server with a synchronous package to tell, okay, server, I want to connect with you. Then the server sends the sync acknowledge package saying that, okay, client, I can also connect with you. And then the clients finally acknowledge, okay, let's have the conversation now. So this three-way sync provides the insurance that the data between the client and the server is received. So, and then the client makes a request. So, and as you can see this, because we need to do three network trips now, the TCP is generally slower than the UDP. So UDP, the main benefit of UDP is speed, while the TCP ensures data validity. And there are some branches of these protocols. So the first, and how basically the web runs, is the HTTP protocol. The HTTP 1.1 is based on TCP, and there is also HTTP 2, which is basically the new protocol, but it still inherits the properties of HTTP 1, and it's still backed by the TCP. And there are also WebSockets. So WebSockets slightly different because they do not utilize the HTTP 1. They use TCP for you the protocols. First, the second one is to chat with employees. what are the technologies we would use for that, and what is the stack? So let's first overview the protocols available to us. So there are two main protocols. One is UDP, and what is the stack? So let's first overview the server. Imagine that we're trying to build the shop administration app with two main endpoints. The one is to track new orders. The second one is to chat with employees. What are the technologies we would use for that, and what is the stack? So let's first overview the protocols available to us. So there are two main protocols. One is UDP. The second one is TCP. The UDP is the protocol that doesn't guarantee the package the package from the server received in the full size, or you can. So when you receive the data from the UDP app with two main endpoints. The one is to track new orders. The second one is to chat with employees. What are the technologies we would use for that, and what is the stack? So
Navigation timings are metric measuring a browser's document navigation event. Resource timings are detailed network timing measuring regarding the loading of an application resource. Both provide the same read-only property, but navigation timing measure the main document timings, whereas the resource timing provides the time for all of the assets of resource call by the main document here. Okay, then you have performance timing API. Performance timing API. Okay, and the performance navigation API. Okay. Fast site provide better user experience. User want and expect web experience with content that is fast to load and smooth to interact with. Two major issues with web performance are issues having to do with latency, and the issue having to do with the fact that the most part browsers are single thread. So exact, and it means that because it's a single thread, we are going to deal is with the complexity that single threads programs actually face, and that is not the sequentially, okay, this concurring way of processing tasks that overlaps in time. So because of that, right, this is relevant to web performance, something that we can control up to a certain point, right? The other is network latency. How long does it take to transmit bytes over the air on the computer? This subtle distinction here is something that we need to know as a way to understand this. For the most part, browsers are considered single thread. That is, they execute a task from beginning to an end before up another task. For smooth interaction, the developer goal is to ensure performance side interactions, performance way of how this web application is perceived, of how now this tasks that happen one after the another are perceived faster. From smooth scrolling to being responsive to touch, render time is key. So it means that browsers even browsers, is running all of this process one after the another. When they say is a browser are single thread, it means that also the it means that also the okay, is the critical rendering path a single thread? That's a good question, man. That's a good question. Okay, is the critical rendering path in the browser single thread? Yes, the critical rendering path in the browser is largely single thread. It means that I have all of these tasks that I need to do per the threads, per queue. You can imagine this pretty much like when you have when you are in the Six Flags and you want to get into a roulette. Okay, you have now you have now 4 lines that this where you can now you have 4 lines where each person can get into at the same time. So in this case, because it's a single thread, it's like we have 1 line, all right, where now the browser is processing all of this task, all of these phases on the critical rendering path. Holy F. So the DOM and the CSS object model is single thread, as well as the render, as well as the layout, and the paint, and the composite. Holy moly. That's, oh my god. So it is quite interesting why you never, and I know why this is imperative, to block the main thread, to block the UI threads. Exactly, HTML parsing, CSS parsing, JavaScript execution, okay, JavaScript run on the main thread too. If a JavaScript file block, for example, it is synchronous, it parsing, delaying further step in the render path. Once it create that, now it need all the necessary information, the browser with the render 3 to actually, exactly, once the DOM and the CSS object are combined to form the render 3, the browser computes the layout, the geometry, and the position of all of these elements, and then finally paints it or renders it, translate that into a bitmap, and compose it, because there is another phase where some other browsers have introduced features like off-screen canvas, web worker, and other parallelization techniques to offload some tasks. For example, where worker can handle non-UI JavaScript tasks in the background, but direct manipulation of the DOM remains single thread to prevent inconsistencies or rate conditions. In essence, while the main rendering process of the critical rendering paths are single thread, modern operations allow other aspects of web application to benefit from multi-threading. But all of this is not JavaScript. This is web APIs. This is the web platform that provide these convenient things. Web workers is just creating a new thread with a new process as a way to close the gap between this communications that you can create when you have several JavaScript instance of the JavaScript engine running per threads. It means, okay. However, now that we know, oh my god, now that we know that the critical rendering path is single thread, okay, when it comes to understand now the network here, one of the goals of web performance is to minimize the amount of time navigation takes to complete. And the navigation is the first step of loading the web page. Exactly. In ideal condition, this usually doesn't have to take too long. The first step is to navigate into a web page It finds where the assets for the page are located. If you navigate to the HTML page is located on the server with IP address of this. If you never visit this site, DNS lookup must happen. And DNS lookup is this dictionary that contains the name of the, you can think of this as a dictionary, right? What contains is now the name of the URL and the value of the IP address, right? So now the package all the information. So now the package now have all the information needed to be sent to its receiver. So your browser requests a DNS lookup, which is eventually filled by a named server, which in turn responds with an API. And after this initial request, the API will likely be cached for a time, which speeds up subsequent requests by retrieving the IP address from the cache instead of contacting a named server. So DNS lookup usually only needs to be done once per host name for a page load. However, DNS lookup must be done for each unique host name that requests page reference. Exactly, for any unique host name that requests page reference. If your font, image, script, ads, and metrics all have different domains, a DNS lookup will have to be made for each one of them. So this can be problematic for performance, particularly on mobile network. When a user is on the mobile network and each DNS lookup has to go from the phone to the cell tower to reach an authoritative DNS server. The distance between a phone, a cell tower, and the named server can add significant latency. So once the IP address is known, the browser set up the connection. Exactly. So once the IP address is known, based on this DNS search, all right, which is provided by the phone company for the ISP to do that. This is quite interesting. This is the first step of this, right? So initially is when you are navigating, so when the user is navigating to a particular web, okay? So the browser now is, if this is the first time to navigate into this URL, then it needs to send the request to a DNS server because it doesn't know that. So that request that go through, so that request that go through the OC model, which is the way of how now different computers with different architectures, they can now intercommunicate. The open standard, the open system interconnection, which is made of the application, the system, the transport layer, then the network, and it's on the transport here that is going to be add certain data, okay, to this data that you want to send to this request. What it's gonna tell them is, hey, this particular data we're gonna send is now TCP or UDP, depend of that, right? Who decide that? You can, as an author, or the application that is using, that you're using, in this case the browser, right? But because depend of the protocol you are using, especially in HTTP, which is now a connection-based protocol, which means is that TCP, right? And TCP is that connection-based protocol, right? Is stand for Transfer Protocol Transmission. Shout out to Vincent Cerf and Robert Ken. Totally, man. Jesus, you must be mathematicians. Yeah, you must be mathematicians. Yeah. My French toast guy, bro. Oh, leave French toast. Mathematician, right? It's a student. Oh, interesting. Is an electrical engineer. All right. Along with Vin Cerf, first proposed the transmission control protocol and the internet protocol. Ken won the Turing Award, and Vin Cerf won their work on TCP. Oh my god. Mm. Mathematics and computer science. And the mathematics is not only exclusive for computers or engineers, right? It's also relevant for musicians, artists, athletes. We are all bind together. All right. Yeah, Vincent Cerf, Robert Ken. Interesting. Some problems with the sampling of modulation signals. Interesting. Yep. Holy moly, bro. This is quite interesting because they developed this with ARPANET. Okay. In 1972, he demonstrated the ARPANET by connecting 20 different computers at the International Conference of Computer in Communication. That must be wild. It's like, what in the F are you doing, bro? This looks like black magic. In 1972, he joined the Information Processing Techniques Office within DARPA. He helped develop the TCP/IP protocols for connecting diverse computer networks. After he became director of the IPTO, he started the United States government $1 billion strategic computing initiative, the largest computer research and development program ever undertaken by the U.S. federal government. After 13 years with DARPA, Ken left to found the Corporation for National Research Initiative in 1986. As of 2022, remains it is chairman, CEO, and president. Damn. Private corporation, man. Corporation for National Research Initiative is a non-profit founded in 1986 as an activity center around strategic development of network-based information techniques, including the national information infrastructure. CNRI form operated the secret of the Internet Engineering Task Force. Guido van Rossum, which is the creator of Python, exactly, pioneer for open source software and creator of Python, at one time worked for this company. The formation and early founding of the Internet Society were led by CNRI. At the first meeting of the Internet Society board, Vince Cerf, representing CNRI, offered in the event of deficit occurred, CNRI has agreed to contribute up to $102,000 to offset it. In 1996, it's okay. Good about this. But the thing here is that now you create that, okay? Vincent Cerf and Robert Kent award the Presidential Medal of Freedom. Ooh, dancing. Oh shit. Oh man. Okay. Yeah. Right now you're not able to see what I'm doing. No, what I'm actually looking is at the. Whew. Yeah, what I'm actually looking is at this. The DCP, right? Which is. Let me do this on English. That's right. There you got it. Exactly. And this is Internet Protocol Suite, which is a fancy name to actually group all of these protocols into one, right? the Internet Protocol suite. Exactly. But as you can see here, so the idea of looking at this is to understand that the way how now you communicate to another computer, regardless the shape, you can imagine that regardless their background of that person, Chinese, Middle East, South Africa, Middle Africa, Latin America, despite of his background, we need to find a way to understand each other, right? Some sort of system, okay? So we all agree that English will be the way to actually do that, because we were forced to do that. So yeah, it's like good, deal with it. But we reached to that some sort of consensus about English is the way of how can we now talk in this business. So it's a way to exchange value here, because this is something important as a way to close the gap in your knowledge, especially when you're talking out to the network. Okay. In the interest, yeah, especially when you need to talk about the network. So by understanding now that the network connectivity here, the network connectivity here, is a way of how. Okay. So let's take a look. Let's take a look at how. Yeah. So let's take a look at how we communicate with our server, right? It's important to understand now the inner mechanism of that.
So let's first how we talk to this server. Imagine that we're trying to build the shop administration.
Right. So if we're trying to build this, if we're trying to build a shop admin, right? A shop admin app that communicates to track new online orders, right? Which is to communicate to track new online orders. Right? To track new orders, endpoint. So endpoint and chat endpoint, right? That's right. So if we're trying to build a shop admin app that communicates to track new online orders, endpoints, and chat endpoints, so we need to know how these things work.
An app with two main endpoints. The one is, so let's new orders. The second one is to chat with employees. What are the technologies we would use for that?
So what are the tools, technologies? So what is the path, you know? So what are the things that we use to do that, right? So that's why we need to look at the OC model. The OC model. The OC model. You like it or not, we need to take a look at the OC model. Sorry, not sorry. I want to know also is the OC model here. Yeah, but in English, please. All right. The history of this, exactly. The development of the OC model started in the late 1970s to support the emerge of diverse computing networking method that were competing for application in the large national networking effort in the world. So you are talking here about the protocols war. God damn. The protocols war were a long-running debate in computer science that occurred from the 1970s to the 1990s. We're talking about roughly 20 years, man, when engineering organizations and nations become polarized over the issue of which communication protocol will result in the best and most robust network. This culminated in the Internet OC standard war in the 1980s and early 1990s, which was ultimately won by the Internet Protocol suit by the mid-1990s, when it became the dominant protocol suited through rapid adoption of the Internet. But this becomes quickly adopted. In the late 1960s and early 1970s, the pioneers of packet switching technology built computers network providing data communications, right? That is the ability to transfer data between nodes. Stream data, so transfer data. As more of this network emerged in the mid-late 1970s, the debate about communication protocol became a battle for access standard. An international collaboration between the several nations, post, telegraph, and telephone, provided a commercial operators led to X25 standard. Interesting. In 1976, which was adopted on public data network, providing global coverage. Separately, proprietary data communication protocols emerged, most notably IBM System Network in Architecture in 1974 and Digital Equipment Corporation's Descent 19. Okay. So now open communications or open public network architecture came in. So this is public and this is now private, right? But the question is that which now remains here? And they still using that. Interesting. Is DNEC still a interesting? It's a standard protocol switch for packet switching communication in wide area network, but this is a protocol. Holy moly. My respect, my lords. Major contributor to CCC. Okay. Worldwide Public Data Architecture. Relations to the OC reference model. Okay, X25 predates the OC reference model. The physical layer of the OC model corresponds to the X25 physical layer. The data link layer of the X25 data link layer and the network layer of the X25 package layer. The X25 data link. So as you can see here, televideo terminal model 925, made around 1982. Jesus fuck. Oh my god. Okay. Okay. This is very this is very okay. Okay. So So this is why we need to look at the OC model. But ask yourself, how can we communicate different computer systems? So different architecture and OS, all right, in an effective way, in an effective and a standard way. So exactly, so we exactly in an effective and a standard way, so we can collaborate much more effective. So we can coordinate and collaborate much more effective, which is something that the capitalists, you like it or not, is all about resource coordination, asset management here. Absolutely, man. Abso-freaking-lutely. So, much more effectively. In an effective, how we can communicate different in plural computer system in plurals, different computer system. How can we communicate with different computer systems in an effective and a standard way, so we can coordinate and collaborate much more effectively? That's one of the mathematics here. Is like, Jesus fucking Christ, Jesus fuck French toast guy, Jesus. So that's why. That's why there is a period in history known as the protocol wars. Okay, so between public and proprietary, between public and proprietary, X.25 was used in public networks. Okay, makes sense. And it predates. Interesting. And it predates that. Interesting. And it predates that. Jesus, French knows that. And it predates that. Exactly. This is a protocol for packet switching, data communication in wide areas. Exactly. What's used in public area? Exactly. A package. Okay, a package similar like UPS or UPS. Or any delivering systems or any delivery company, all right? UPS, UPS, the delivery package companies. Amazon is another one. FedEx, DHL, the Deutsche, okay. FedEx, DHL, UPS, all right. Coordinate is something that is a challenge in itself. So this X26, which is a package protocol, is a package exchange, right? Packet switch, data communication is a package switch. It's a packet switch Okay. For package switching. Package switching, exactly. Okay. Damn, son. So it's a package switch. It means that that particular package you're gonna send, it's gonna pass through several postcards until it reaches the destination. It can be the same, it can be the different, but all of this is gonna pass through all of this switch. Okay, all of this postal office until it reaches to the destination. So packet switching, interesting. Packet switch data communication. Packet switch data communication in wide areas. Exactly. Packet switch data communication in wide areas. In wide area network. In wide area network. Not local. Globally, if it is possible. Mm-hmm. Mm-hmm. So this protocol, the X25, which is a packet switches data communications in wide areas network, okay, was used in public, and it predates what now we know as the OC. This open system interconnection. Jesus, French stuff. Interconnection. Exactly. The OC model. The OC model. It's important to understand this. Right? It's very, very important to understand this. It's very, very, very important to understand this. How is the OC model made of? You may wonder. Well, right now, 7 layers, where each particular layer is going to add some information, add some piece of data to this data that you want to send over, as a way to now have everything it needs to send over the cable over the air. That it reach now to the destination here. Damn, son. So it is made of 7 layers, where each layer adds specific data relevant to communicate. Okay, interconnection, data relevant to communicate with another computer system, whether it's a mobile, whether it's a mobile, a tablet, IoT, exactly, mobile, tablet, IoT, desktop, you name it, any other computer system, a system that can compute. Oh crap. All right. So this particular model here, human computer interaction layer, where application can access to the network service. The presentation layer ensure the data is usable, is an usable format, and it is where the data encrypted occur. Interesting. Okay. Okay. Again, I don't need to dive deep too much in this. Just know enough to know what happened in each one of those phases, because what we really care about is that how can we use what are the things that we need to know as a way to get into this, as a way to communicate that, what are the protocols that we can use for. So we're going to be very specific about what we really care about this. Okay, so you got now the here 7, why not? Okay, okay, we say 7, that's quite interesting. Anyway, so you got now is the 7, no, you say no, application, this is the application layer, this is now layers. Okay, the applications. Okay, so in this phase is now when the human-computer interactions, exactly, human-computer interactions happen in those applications, where application exactly happens, where applications can have access to network services, right? In this case, the network service provided by the OS. The presentation layer, okay, you got 6, presentation. So this presentation layer is when encryption occurs. Ensure that the data is usable format. Okay, ensure that data is in a usable format. Interesting. And is where data encryption occurs, and is where data encryption occurs, right? Makes sense. The other is 5, SYN layer, maintains connection and is responsible for controlling ports and SYN. So this layer is maintain connections. Interesting. So maintain connections. Interesting. Especially useful when you open a port, when you want to communicate to a database, for example, right? PostgreSQL. So it maintains the connections for that. Maintains connection, and it maintains the connection, and it is responsible for controlling port and SYN. Maintain connection, and it is responsible for controlling ports and SYN. Interesting. Then you got now 4, which is the transport, something that I'm quite familiar, right? And here in the transport is when you're going to add now the proper format of which transmission protocol is going to use. Transmitting data using transmission protocol, including TCP and UDP. Transmits data. Okay. Transmit data using a protocol, using transmission protocol. Here is when now the transmit data is added. What is the transmission protocol we're gonna use? Transmit data. Transmit data using the transmission. Oh my God. The transmission protocol. Okay, transmit data using the transmission protocols that it can be TCP or UDP, right? Including TCP and UDP. Interesting. This is the transmission protocols. Okay, so what are the way of how we're going to transmit this data? UDP, transmission protocols. Holy moly, bro. Yeah, but what are those transmission protocols? UDP, okay. Transport layer protocols. Hey, what are the transmission? How we gonna transmit this data? What is the protocol we're gonna use? Transport layer protocols. CubeSat space protocol. Okay, datagram congestions, fast and secure protocol, ill network, multi-purpose transmission protocol, NAC, okay, user datagram protocol, transmission protocol, wireless datagram protocol. Oh my god, interesting. Wireless datagram protocol defines the movement of information from receiver to sender and resembles the user datagram protocol. Internet Protocol suite. The wireless datagram protocol, a protocol in WAP architecture, covers the transport layer protocols in the Internet model. As a general transport service, WDP offers to the upper layer an invisible interface independent of underlying network technology. In consequence of the interface common to transport protocol, the upper layer protocols of WAP architecture can operate independently. Wireless datagram protocol. Wireless transmission protocol is a standard using mobile telephony. It's a layer of wireless application protocol. Okay, it is a layer of wireless application protocol. Interesting. You also have now the but this is if you want to communicate with mobiles. Wireless datagram protocol defines the movement of information from receiver to the sender and resembles the user datagram protocols. Okay, interesting. Resembles to this. Oh my god. Oh my god. Alright, Jesus and French toast guy. So, exactly. It can be is TCP, connection base. It can be TCP, connection base. Okay. Which is connection base, right? So when a handshake needs to happen, when SYN-ACK and ACK handshake needs to happen, okay, and UDP, all right, where we might lose data, right, is one of the core communication protocol in the Internet Protocol suite used to send message to other hosts within an IP. UDP does not require prior communication to send UDP communication channels. Exactly. So it's connectionless. So there is no negotiation. Okay. So it says connectionless. So no negotiation, no data handshake negotiation, great for streaming, great for VOP, right? Voice and IP. Great for this. Exactly. Great for VOP and that kind of thing. Great for VOP, streaming data. Makes sense. Then you have now the internet or the network layer, which is to say, hey, what is the path that we're gonna take here? Then we have now the internet or the network, sorry, it's the network layer, right? I don't want to put this thing here. You think you're funny? Network layer that indicate is, so this is the information that adds to say, hey, which path we're gonna take. Decide which physical path the data will take. Decide which physical path the data will take. And then you got now the data link layer. All right, the data link layer, but once you know what is the physical path that it needs to, so what are the devices that it needs to actually define the format of the data on the network, defines the format of the data on the network. And then how it's going to transmit raw bit streams over the physical medium, and then transmit physical let's get physical. I think there is a song about that, but anyway. So yeah. Okay. Good. And this is so transmit. So transmit. Transmit raw bits of exactly. So transmit raw bits of data through the physical medium, right? So once the data is sent, okay, so now this is OC model, layers, and network travel. Or navigation, right? Or the navigation. So once the user click exactly. So once the user navigate to a particular URL, this data is sent from the browser through the network, or to the network service that implement OC model, a model that is the open system communication, right? The open system intercommunications, right? To transmit data to the ISP. If this is the first time we navigate to that URL, and then they send that to their DNS server, which holds, okay, and then to their DNS servers, which hold registry of URL names that knows the IP address. Okay. So far so good, right? And then, so DNS lookup usually need to be only once per host name. Okay. The browser catch that usually. Okay, so the browser likely catch such IP, and we need to do usually DNS lookups per host name, right? So we have to do that. You have to do all of these DNS per lookup. So lookup must be done for each unique host name, right? So and this can be problematic for mobiles. Yeah. So this can be problematic for mobiles. So once the IP address is known, so once the IP address is known, okay, then the TCP handshake, which to me is quite interesting. So once the IP address is known, the browser set up a connection to the server. So once the IP address is known, then the browser set up a three-way TCP connection handshake as a way to see, hey, is someone there, bro? There, are you there? Hey, bro, are you there, bro? Okay, which is this one. The browser set up a TCP three-way handshake, right? So far so good. This is when we have now the TLS negotiation, which is SYN-SYN-ACK. Accurately, SYN-SYN-ACK. Before there are three messages transmitted by TCP to negotiate and start a TCP system between two computers. Yes, this means three more messages back and forward between each server, and the request has just to be made. Holy hell, you know. So, it means three messages sent before we communicate with the server. Okay. Yes, this means three more messages back and forward between each server, and the request has just to be made. So it means that three messages back and forward, SYN-ACK and ACK. Okay, so it means three messages back and forward, SYN-SYN-ACK, and then the request has just to be made. So before the request is yet to be made, right? Okay. So what we have now, this particular animation here, which is this one, which is gray. The animation or the visualization image. That's right. So you get this one, screenshot too. There you got it. Okay. Okay. So secure communications. Secure communications. For secure communication established over HTTPS, another handshake is required. Right. So this is DNS lookup. This is DNS lookup, and then we can talk about is the DNS lookup. We say DNS lookup. Okay, so DNS lookup, and then you have now is the TCL, TCP handshake. Okay, and secure communication, right? TLS secure. So I need to add a new TLS negotiation. TLS negotiation, which is secure communication. TLS negotiation for secure connection, which means encrypted, which cipher will be used to encrypt the communication. So here, for secure connection, this adds another handshake to set up which cipher will be used. Handshake. Determine which cipher will be used to encrypt communications. Ciphers used to encrypt communications over TLS. So ChatGPT here, come to me. Asymmetric, symmetric, hashing. Okay, it's interesting. Asymmetric encryption or public key, symmetric encryption, data encryption. Okay, so it can be asymmetric encryption. Interesting. Asymmetric encryption, symmetric encryption or data encryption, symmetric encryption. Yeah, symmetric encryption here. Oh my god, for real? Enough, bro. Symmetric encryption. Then you got is the AS, Advanced Encryption Standard, or CHA 20, or CHA 20, right? Where now this advanced encryptions, the most widely used available is various key length with this. Okay, so key length of 128, 250, and okay, because it takes too much time exactly to do that. And the other is used with poly 13 for high-speed encryption and integrity checks, especially on mobile devices when hardware IS acceleration isn't available. For high-speed encryption, interesting. For high-speed encryption, interesting. All right. Interesting. Okay. And the other is hashing algorithm. Hashing algorithm. Like SHA. Okay. Like SHA. Interesting. SHA 256. SHA 256 and SHA 304 and SHA 384. Interesting. Very, very, very interesting, by the way. Diffie-Hellman and elliptic curve. Interesting. So RSA. Exactly. RSA. Diffie-Hellman. Diffie-Hellman, which is used in public encryption. Asymmetric encryption secures an initial handshake between the client and server. This is interesting because this is all of the particular algorithm that is using when it comes to secure your connections. TCL negotiation that adds another handshake as a way to know which is the encryption that we're gonna use, which is the cipher, which cipher will be used. Hey, we're gonna use this now asymmetric encryption, which means that you have a public key, you have a private key, RSA, Diffie-Hellman, or we're gonna use now symmetric encryption or data encryption, right? So we're gonna use is the AIS 128 or 192 or 205. This is the length of the key. It can be too long because otherwise it makes the applications very, very slow. Or cha-cha 20 for high speed. And then you also have is the hashing algorithm. Interesting. So it's like SHA 256 and 308. All right. Okay. So once that is done. Okay, so once that is done, so once we have established the connection, the web server, the browser sends the initial HTTP GET request on behalf of the user, which for the website is most often the HTML file. So, exactly. So after that, the response. So after we have established the connection with the server, then the browser sends an initial HTTP GET, or the option as well. The browser send an initial HTTP GET, where usually, which is for website, is most often an HTML file. Exactly. So once the server, so the browser set an initial HTTP GET request, which is for a website, is most often an HTML. So once the server, right, receive it, now send a response with usually an HTML, right? So that's so far so good. It's like nothing too fancy, nothing too complicated. The only thing is that just as a way to create this narrative, to understand how do we get here, that I think this is very, very relevant and very, very important, my friend. Oh yeah, it is, man. So this is now to describe is the network connectivity. Describe the path. Network connectivity. And we're not done. We are definitely not done.
And what are the videos that they finally acknowledge between the client and the server? One is based on TCP, and there is also HTTP2, which is basically the new protocol, but it still inherits the properties of HTTP1. Network trips now. The TCP is generally slower than the UDP. So UDP, the main benefit of UDP is speed, while the TCP ensures the data validity. And there are some branches of these protocols. So the first, and how basically the web
fundamentals as a way to understand now.
Fixing McDonald's ice cream machines just got easier. If you've ever wondered why McDonald's ice cream machines are always broken, there's actually a pretty good reason. The software that runs the machines is copyrighted work. And the law states that only the manufacturer of the equipment can bypass the digital locks to provide maintenance. But the U.S. Copyright Office recently granted a key win to third parties, allowing them to diagnose and fix commercial equipment, including the machines that make McFlurries. Okay. Fixing McDonald's. Son más o menos 4 gramos o kilogramos de peso. Por eso creo que estás quedando muy corto en carbohidratos. Para hipertrofia es más o menos la cantidad. Ponele que negociemos la mitad. Y bueno, tratar de que sean 160.
Son 4 kilogramos por... Son 4 gramos de... Son 4 gramos por kilogramo. No, ni en pedo. No, ni en pedo. No estoy muy bien con la grasa, amigo. 4 gramos por peso. No, fuck that. No, fat, bro, fat. Mine is fats. All of the things come from fats. Okay.
Run the TCP speed while the TCP ensures data validity.
So you may wonder, what in the F is HTTP? Right? What in the, because we're talking about is that, yeah, you're sending this, okay, now the browser established the handshake, okay, so now the browser established the handshake, TLS negotiation for secure connection. These are another handshake for that, right? And then you get a response. So so after you establish the connection, whether it's normal or secure connection, TLS negotiation, by adding is this new handshake where it's going to agree which cipher they're going to use, whether it's asynchronous, asymmetric encryptions, which is using public and private key, right? Using the RSA algorithm or the Diffie-Hellman, or you want to encrypt the data by using this algorithms like Cha-Cha-Cha 20. I remember that because it's very Latino, it's like very dancing. Cha-Cha-Cha 20 to speed up its encryption, especially for mobile applications, as well as the ASS, the Advanced Encryption System. Advanced Encryption System, right? It is. The Advanced Encryption Standards, that now it provides you a length of this key that is 128 or 192 or 256, you know, or the hashing, which is using now, for example, SHA-200 256 or SHA-304 in any case. But once you establish this, all right, after that the browser sends an initial HTTP GET request. What in the F is this HTTP GET? That's a valid question. That's a very, very valid question. HTTP here, right? Exactly. It's an HTTP request. So HTTP, which is hypermedia transfer, this is hypermedia transport transfer protocol. It's like, hey, this is now the particular way of how we're going to transmit this piece of data, this content, this HTML, all right, or this hypermedia, okay, which indicate the purpose of the request and what is expected if the request is successful. Also, they can also be known, these request methods are sometimes referred to HTTP verbs. This particular protocol, where we are going to agree to transmit this hypermedia documents, this document that can only not have static content but also media on that. That's what they call hypermedia, because you can in a paper you can have right now is video or image yes, but video does not, right? So that's what they call hypermedia, and this is made of that particular verbs, right? So again, this is a protocol. Each request method has its own semantics, but some characteristics are shared across multiple methods. Specifically, request method can be safe, idempotent, or catchable. So is this, right? This is the protocols that we're going to use. Reference HTTP, that's right, an overview of the HTTP, exactly. So once now these two computer systems has agreed to now share data, to communicate, to talk each other, now when it comes to actually send this particular data, this particular package, okay, now they can say, all right, this is the way of how we're going to communicate in order to send or receive this data. So how can we translate it into a real life? So if you want to know okay. So let's say you go out for an ice cream, right? And the handshake here, the TCP connection, is the way of how we're going to communicate each other. This transport, and say, hey, I want you to now first establish this communication. Is like, I'm going to look at you, and until you look at me. And when you look at me, right? So we are now sync. So now we can start to talk. This is how this handshake initially came. And then I'm going to ask you for an ice cream. And the way how I ask you for an ice cream is, well, telling you what are the things that we can do. In this case, hey, I want an ice cream with these 3 flavors, then sparkling things, and you're gonna do that. But this is the overall idea of how you can translate this handshake and then the HTTP protocol. Again, this is our way of how you're going, in this case, transmit this data, right? It's like, hey, pretty much if you have an Uber, all right, and then you, for some reasons, you forgot your keys, and then your mom or your dad or some of your colleagues say, hey, you forgot your keys. It's like, hey, I'm gonna send you to I want to send you that. All right, when, how, where, right? Well, let's gonna use this Uber for that, or Didi, or any other transport application, right? Okay, so we got HTTP, HTML, CSS, Web API. Okay, wait a single moment. So this is a protocol, right, for fetching resources such as HTML document. Okay, and they talk about protocols here, which is a systems of rules define how data is exchanged between computers. This is what is like, the language is something different, because a protocol says like, this is the set of rule of how we're going to exchange data. How we're going to exchange value data here. But that's the end goal of the protocol. So how we're going to exchange value. So client server communicate by exchanging values here. So this is the web, HTML, CSS, Web API, JavaScript, the client. This is the way how we're going to send that data. That actually is using the DNS, the TLS, UDP or TCP, and then the IP. So the components of HTTP base systems, right? You have the client user agent, the web server, followed by the proxies. The basic aspect of an HTTP. HTTP is simple, extensible, stateless, and connection. What can be controlled by HTTP? Here's a list of common features controllable by HTTP. Interesting. So caching, relaxing the origin constraint, authentication, proxy and tunneling, and seasons, and HTTP flow. Okay. This is now the method here, and followed by the response. API based HTTP, and there you got it. This is something interesting because most commonly used API based on HTTP is the fetch API, which can be used to make an HTTP request from JavaScript. The fetch API replaces the XML HTTP API. Another API, which is something that we are not familiar with, is the server send event. It's one-way servers that allow a server to send events to the client using HTTP and as a transport mechanism. Using the event source interface, the client opens a connection and establishes event handlers. The client browser automatically converts the message that arrives on the HTTP stream into the appropriate event object. Then it delivers the event handlers that has been registered for the events type, if known on the on message here. This is something interesting here, because I am not quite familiar with that.
And there are some branches of these protocols. So the first, and how basically the web runs, is the HTTP protocol. The HTTP 1.1 is based on TCP, and there is also HTTP 2, which is basically the new protocol, but it still inherits the properties of HTTP 1, and it's still backed by the TCP. And there are also WebSockets. So WebSockets slightly different because they do not utilize the HTTP 1. They use the HTTP 1 only to initiate the first request for the server, and then they upgrade to TCP. So it's basically, the WebSockets are fully TCP based. And there is a server send events that are based on HTTP 2, which is the server push technology. And we're going to look at all of these protocols just in a few slides. Then there is a UDP. And UDP, there's a protocol developed by Google called QUIC. And QUIC is using the UDP under the hood. And the new protocol, HTTP3, is actually based on the QUIC, which is based on UDP. So we are moving from TCP to UDP soon for the HTTP3 protocol. And also there's a WebRTC, which is so we are moving from TCP to UDP soon for the HTTP3 protocol. And also there's a WebRTC, and QUIC is using the UDP under the hood. And the new protocol, HTTP3, is actually based on the QUIC, which is based on UDP. So we are moving from TCP to UDP soon for the HTTP3 protocol. And
HTTP3 protocol. Interesting. That's very interesting. That's very interesting. Exactly. It removed that handshake. Because connections are secure by default. Interesting. Okay. Interesting, my friend. So HTTP 3 is okay.
Also there's a WebRTC, which is used for the streaming, and even this stream now is streamed probably through the WebRTC net. Okay, probably through the WebRTC net.
This is network connectivity protocols. So now here we're looking is at the network connectivity protocols. Okay, that's quite interesting. And as a way to have now more secure
Okay, let's get back to the examples with our application example. So we have the first endpoint, getting new orders. So how would we design this? So the first thing that we could use is the technique called long polling or short polling. It's basically making the normal get call every specified time frame, for instance, every 20 seconds. And it's very easy to implement. So we can set up the interval and use the fetch request and call the server every 20 seconds. So what are the issue of the long polling for getting new orders? So the first one is the HTTP protocol. Since we need to establish the three-way handshake with the server, it's relatively slow. It will be pretty slow. And when we establish the HTTP connection, we open a new TCP socket. And TCP socket apparently takes CPU, and it also drains energy as a result. And it also has the property of an inefficient network usage, because when you establish the connection with the server, you send the metadata, which is the headers, with the request. And if you are on HTTP 1, then the header data is not compressed, and you may end up sending 50 kilobytes every request of just header data. And HTTP 2 improves the situation by compressing the headers but we still have this three-way handshake that we need to establish. And there is one thing is that the long polling and short polling actually drains the battery of the mobile devices, because you need to maintain your TCP socket open. And when your TCP socket is open, the key thing how the mobile module is structured. So in your phone, you have your mobile network module has two modes. One is mono. It's basically receive only. When this module in the receive only mode, so it's very energy efficient, but it can only receive the data. But there is also a duplex mode where you can send the data and receive the data, and it's not energy efficient as a result. So when we use the long polling, the mobile device utilizes a duplex antenna. So it receives the data and sends the data. And if we run the quick experiments, for instance, we have the 2000 battery, and we know the average energy drain. So it takes only almost 4 hours to drain the full battery by maintaining just one socket opened. And I attached a link to the research paper that you can use to, if you're interested in reading the whole paper. So this is the problem number one, CPU utilization and energy drain. So this is not an issue for desktop apps where we don't think about the battery of the device because we are connected to, we are plugged into energy network. But this is a big deal for the mobile devices where we need to be very network and energy efficient because we have limited network bandwidth and the battery. The second problem is the latency. The long polling and short polling latency can be an issue on mobile devices. And this happens when, for instance, you're on the fast train or in a fast car, and then you're connected to some network tower. So then you sit on your train, you may end up losing the connection and reconnecting to the new network tower. So now you need to reestablish the connection again, send the headers, and do the three-way handshake. And if you change your network towers multiple times, imagine that the latency can be significantly increased. And also, the problem with the long polling is that you need to re-implement the reconnection. Every request to the server, which is done through
the problem with HTTP polling is that you need to implement
the REST API is stateless, so you don't know exactly. You will lose the state, and you will need to re-implement some infrastructure on the server side to do this. So it's in the long run for the mobile applications, it actually costs more to support the long polling, money-wise, of course. So what is the summary then? So the long polling is very good. It's very easy and cheap to implement. And definitely there is no additional infrastructure required unless you work with the mobile apps. If you work with the mobile apps, then there is an issue with that it's not battery efficient because it's used CPU to maintain the TCP socket. And it's also not network and data efficient because you're sending the headers with the request when you do the three-way handshake and when you try to request the data that you are trying to receive. And if you're on HTTP1, the situation is even worse because HTTP1 sends too much overhead data. And so what is the use case then? The use case is actually for the long polling can be used with desktop apps where we don't care about the network bandwidth and also about the latency because we're stationary. We do not connect to different mobile towers, and also we do not care about the energy drain. So it's also pretty cheap to implement for desktop users, and it's pretty well suited. But when it comes to mobile web application, then you would need to consider it.
But this is network applications, and other network considerations are discussing, including energy consumption and latency. This lesson also includes the pros and cons of using long polling, which is part of the network, which is one of the mechanisms, one of the way of how you can communicate that, right? Network connectivity, and that is long polling. So. Methods. Okay, so okay. Mm-hmm. 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 Again, because this is our techniques, bro. Mm-hmm. Mm-hmm. This is okay. This is not this techniques to communicate with the server or communication technique. Mm-hmm. So we got now is this as it is. So long polling, server send event WebSocket that makes a lot of techniques, bro. Very interesting. Very interesting. Long polling, server send event, WebSocket, and REST and GraphQL. You know, REST and GraphQL. Interesting. But this is communication techniques, bro. Communications techniques. Communications techniques. It's easy to implement. No additional infrastructure is needed. 99.9% of the server will support that, because what you're doing is just sending data to that. So we have now is the long polling. Long polling. Interesting. Interesting here. Long polling. Okay. That'll be all for this video. Okay. Yeah. Long polling. Bye bye.